All right, video number 2. This one is on multiplying decimals, which you're going to find is very similar to traditional multiplication, which we're already pretty good at. Get our title, multiplying decimals lesson up top. Get our date in the corner along with your name. And then our essential question. How is decimal multiplication similar to traditional multiplication? When you're ready to go ahead, we'll get started with our lesson. So first off with decimal multiplication, it's always good to do a quick estimate. It's going to help us when it comes time to placing that decimal point in our answer. So here I want to do 5.8 times 4.1. So kind of round off each number. 5.8, that's about 6. 4.1 is about 4. So I'm going to expect an answer somewhere around 24. Over here, 3.15, well, that's about 3. 2.9, well, that's almost 3. 3 times 3, so we're going to expect an answer somewhere in the range of 9. That's going to help us when it comes time to placing that decimal point. So let's go ahead and do our multiplication. When you're actually multiplying, ignore the decimal point. It really has nothing to do with the multiplication. We start with our first number 1. 1 times 8 is 8. 1 times 5 is 5. So now we're done with the 1. We're going to move over to the 4. Remember, when you start that next row of multiplication, we're not really multiplying by 4, we're really multiplying by 40. It's in the tens place. So we add in that 0 placeholder because we're not multiplying in the ones anymore. We're going to start in the tens place. 4 times 8 is 32. So our 2 goes down here and we carry the 3. 4 times 5 is 20. Plus 3 is 23. When we're done, then we go ahead and add our partial products together. 8 and 0 is 8. 5 and 2 is 7, 3 and 2. And then remember, we want an answer that's close to or approximately 24. So think about where would I put a decimal in this number so it's going to give me something close to 24? Well, right here would make sense. 23.78 is awfully close to our answer of 24. Next one, a little bit bigger. 5 times 9, because we always start with this first number and this first one, gives me 45. 9 times 1 is 9, plus 4 is 13. Carry the 1. 9 times 3 is 27, plus 1 is 28. So now I'm done with the 9. I'm going to move over to the 2. Remember, to do that, you got to start with that placeholder 0, because we're now starting in the tens place, so our work is going to start right underneath of it. 2 times 5 is 10. Carry the 1. You can cross out our old carry marks if those get in your way. 2 times 1 is 2, plus 1 is 3, and then 2 times 3 is 6. Now we're going to go ahead and add them together. 5 and 0 is 5, 3 and 0 is 3, 8 and 3 is 11, carry the 1, 1 plus 2 is 3, plus 6 is 9. And then we go back to our estimate. We expected something in the range of 9. So we know our answer is not going to be 9,135. We need to put our decimal in there. The way we do that is, since we know we want something close to 9, I'm going to put it in here. So I get 9.135. That's awfully close to our estimate of a 9. So now I want you to do a little pondering. And you might even remember this from elementary school. But rather than estimating, how else could we have figured out where to put that decimal in our answer? So look at the problem. Look at where the decimal ended up. Is there anything about the problem and the numbers that went into it that would help me know that, hey, I wanted to go 2 places in my decimal point here, or I wanted to go 3 decimal places in my number here? Okay? Oh. So hopefully you thought about it a little bit, and hopefully what you noticed is you don't really have to worry about lining up the decimals, but what you want to do is you want to count how many digits you had in your decimal point in both numbers. That's how many places you slide it over. If I pop back here, you'll notice that I had 2 digits behind the decimal in my problem, so I went over 2 spots in my answer. Over here I had 1, 2, 3 decimal places in my problem, so I went over 1, 2, 3 decimal places in our answer. Notice that that method got us to the exact same answer that we expected from our estimate. So here's our rules that we want to copy down for multiplying decimals. First, don't worry about lining up the decimal point. You're just going to go ahead and multiply your numbers. Then go back and count how many digits you had after the decimal point in both numbers. That's how many places you slide the decimal point in your answer. So let's see that in action. Start by just doing your multiplication. 8 times 1 is 8. 8 times 0 is 0. That's an easy one. 8 times 3 is 24. Oh. Next row, I'm going to start with that 0 because I'm done with the 8. 1 times 1 is 1. 1 times 0 is 0. 1 times 3 is 3. Add them up. 8, 1, 4, and 5. And then go back and look at your answer again. This was about 3. 1.8 is about 2, so we're going to expect an answer around 6. So think about where you'd put your decimal in the answer. If we wanted something near 6, I would say there. And then use our new rule. How many decimal places were there in the problem? Well, I had 1, 2, 3 decimal places in my problem, so I came over 1, 2, 3 decimal places in my answer. Notice how it worked out the same way with what I would have expected from my estimate. So let's try that one more time. Bigger problem, you're going to have to be a little bit more careful in making sure everything stays lined up and that you're careful with it. 7 times 6 is 42. 7 times 3 is 21, plus 4 is 25. Carry the 2. 7 times 1 is 7, plus 2 is 9, and 7 times 1 is 7. So I'm done with the 7. I'm going to switch colors here, and I'm going to start with that 0, and now I'm going to multiply by my 4. So I'll kind of ignore those carries. 4 times 6 is 24. 4 times 3 is 12, plus 2 is 14. You're always adding what you carry to the next column. 4 times 1 is 4, plus 1 is 5. 4 times 1 is 4. So now I'm done with the 4, and now I want to multiply by my 1, my last digit. So this time I'm going to add 2 placeholders so that I'm starting underneath of that hundreds place where my 1 is, or sorry, my third decimal place. 1 times 6 is 6. 1 times 3 is 3. 1 times 1 is 1. 1 times 1 is 1. It's always nice to multiply with 1s. Add them up. 2 and 0 is 2. 5 plus 4 is 9. 9 plus 4 is 13. Plus 6 is 19. 1 plus 7 is 8. Plus 5 is 13. Plus 3 is 16. 1 plus 4 plus 1 is 6. And a 1. Now I need to go and put my decimal in my answer. I know an answer of 166,992 is probably not realistic for 11 times 14 or 15. So remember, this is where we go back to the problem and we count up how many digits do we have in the problem. I had 1, 2, 3. So I want to come over 1, 2, 3 places in my answer. My answer was 166.992. So we're at the point where it is your turn. Look back at your notes, look at the steps that we used, and I want you to write down this problem and to solve it for yourself. When you're ready, hit play again, and then you're going to see if you did the problem correctly. All right, so I've got my problem lined up. I'm going to do some quick math so you can compare your answers. 5 times 9 is 45. 9 times 0 is 0, plus 4 is 4. 9 times 6 is 54. Since that last one was a 0, I knew I wasn't getting anything new, so that 5 could come straight down. Done with the 9, so I start that next row with that 0, so I'm starting out under my 2. 2 times 5 is 10. Carry the 1. 2 times 0 is 0, plus 1 is 1. 2 times 6 is 12. Add them up. 5 and 0 is 5. 4 and 0 is 4. 4 plus 1 is 5. 5 plus 2 is 7. And 1. This one's got a lot of decimal points in it. Okay? So I've got 1, 2, 3, 4, 5 decimal points in my problem. So I want to go over 1, 2, 3, 4, 5 decimal places in my answer. So in this case, since there's nothing in front of it, I can add in that 0, and I get 0.17545. See how you did? See if you did well with it, and then we'll practice some more in class.